The flight path and navigation of any aircraft today is fully reliant on the availability of the global positioning system and its operators. If the satellites stop working for whatever reason, or even if the number of satellites is not sufficient enough to determine one's position, an aircraft would have to revert to conventional navigation methods. Imagining this kind of meltdown on a global scale makes you wonder how this would play out. My name is Flo, welcome to Foredeck. First, let's elaborate a common misconception. GNSS means Global Navigation Satellite System and is the general term describing any satellite constellation that provides positioning, navigation, and timing services. GPS is the first one of its kind implemented by the United States in 1978. Today, other systems like GLONASS, Baidu, and Galileo are available by the Russians, the Chinese, and the Europeans are sorta available. In 1994, a significant milestone in American aviation occurred when the Federal Aviation Administration, or FAA, certified the first GPS unit for use in instrument flight rules operation. Today, GPS is the norm, while VORs or NDBs, the conventional navigation methods, have almost been rendered irrelevant. What's the big deal with satellite navigation? In the early days of aviation, radio beacons have been used by pilots to track a specific track to or from a station. This type of navigation often meant that pilots couldn't actually use the most direct route, rather a zigzag course from nav station to nav station. With the introduction of RNAV or area navigation and the later implementation of GPS, an aircraft can track towards any point on Earth. The effects of a GNSS outage are different for every aircraft type. Smaller aircraft navigating visually or VFR should not have any problems, as they are navigating with the help of landmarks, rivers, and cities. But most commercial traffic are navigating according to IFR or instrument flight rules. That means an aircraft flying according to IFR follows a prescribed track between GPS waypoints or nav stations like VORs or NDBs. VORs or NDBs are kind of like a lighthouse for aircraft. With the help of those stations and the signal they send out to any aircraft within its range, the pilot can track to or from the station following a magnetic track. But generally speaking, even if an aircraft is tracking to or from such a station, they are flying to nav stations coded in the flight management computer, so it's still basic GPS waypoints. If the flight plan would consist of nav stations that physically still exist, a GPS failure would not be such a big deal. The aircraft could revert back to navigating conventionally with the magnetic tracks using the station, but the reality is that aircraft will use a combination of out-of-service nav stations, GPS waypoints, and airways, plus conventional nav stations. So flying the filed flight plan without the use of GPS could be a bit of a problem. Big aircraft like the A320, the 737, or even bigger business jet aircraft have inertial reference units, or IRS. All the aircraft might feature an inertial navigation system, or INS, the predecessor of today's modern IRS units. Those systems are standalone units that do not rely on any outside input to know where they are on Earth. The system is made up of laser gyros and accelerometers. The point of it is to sense any acceleration in any direction so as to compute a change in speed and therefore a change in location. For that system to work properly, it has to be initialized by the pilots when waking up the aircraft. The Earth rotates at a rate of 15 degrees per hour. With this information, the system can figure out its latitude and thereafter its heading. Depending on the aircraft type, the pilot has to put in the GPS coordinates manually, as the system cannot determine the longitude the aircraft is on by itself. This is why you sometimes can still find the coordinate numbers next to the gate numbers at the aircraft's parking stand. Because the IRS is a very sensitive equipment, the aircraft has to remain stationary during the alignment process. In windy conditions or small shakes induced by loading of the cargo, the IRS will sometimes fail to align. Also, during the course of the flight, the IRS would start to drift and position might not be accurate anymore. For that reason, the system utilizes updates with the help of the GNSS and various different radio aids and DMEs. That's it with the technical background. Smaller general aviation aircraft or even smaller passenger aircraft like the Dash 8 do not have an IRS or INS. These are the aircraft it gets really interesting with once GPS is lost. In the very unlikely case of a nationwide or even a worldwide GPS meltdown, pilots and maybe even more so air traffic control will have a stressful successful job redirecting and vectoring aircraft. Pilots are expected to only follow the routes they've been cleared for. If the integrity of the GPS is lost, pilots would make a radio call and say Oscar Echo Foxtrot Romeo Golf unable RNP, to let them know we are unable to navigate with our GPS so they can give us new instructions like heading or intercepts and directs to radio aids. If this is the case with multiple aircraft within one area, ATC would definitely work a little bit harder that day. ATC has 4 options they can utilize once GPS is unserviceable. The easiest one is to clear an aircraft for an approach. If the aircraft is still too far away from the aerodrome, it can either be vectored to a station, or given explicit instructions as to follow a radial to or from a nav station. We will now go into more detail looking at these possibilities. Clearing the aircraft for the approach or holding. This can obviously not be an RMP approach or holding fix utilizing GPS waypoints. The best case would be an approach using physical ground-based nav stations with the aircraft performing its own lineup via a holding or base turn. In a perfect world, an aircraft flying to Graz, for example, would be cleared for this VOR approach via the DME arc. Subsequent aircraft could be cleared into the holding and await the approach clearance. Once the aircraft is cleared for the approach, it will track a QDR of 240 outbound to intercept the 12 nautical mile arc for the subsequent lineup with a final approach track of 334 degrees. If the aircraft would be approaching from the north, it would have an even easier job entering either with the racetrack or base turn over the Graz VOR. Vectoring the aircraft. Not all ATC units have radar available, but those that do have the option to give the pilots heading instructions towards the destination. Radials from nav stations or approach fixes could clear them directly to a station. There are a handful of different rules prescribed that are studied by the pilots during their training. These rules are to be applied by any pilot and air traffic controller anywhere around the world. So if a pilot receives a clearance for a hold, for example, there are 3 different ways to enter into that holding. Depending on the direction the aircraft is approaching from, the pilot is expected to fly either a direct, offset or parallel entry. The same kind of rule set applies when cleared onto a radial or flying a base turn. So theoretically, ATC knows exactly what the pilot is about to do once to clear them for a certain task. But there is a catch. Around the globe, they're beginning to dismantle all the non-critical nav stations within the next few years. Only a few will remain which are needed for approaches or missed approaches. In the future, we will more than ever rely on GPS-based navigation and maybe even more approaches. Many newly developed or recently instrument-upgraded airports sometimes rely solely on RMP approaches. They are cheaper, easier to maintain, and faster up and running. In the eastern Mediterranean, pilots will often report a loss of GPS signals when flying towards Larnaca or Tel Aviv. This interference and jamming has resulted in a loss of or inaccurate GPS signals and has affected the airplane's navigation equipment. A global GPS outage is very unlikely as multiple GNSS constellations are running at the same time. So in case of GPS loss within a certain area, ATC would probably take multiple variables into considerations. Dimensions and duration of a GPS outage, which aircraft cannot navigate due to a lack of inertial navigation, how many aircraft can ATC accommodate at a given time, thus the capacity has to be shrunk, prohibit entry of aircraft unable to fly RMP. They will also need to think about the coverage of conventional ATC routes and standard departures and arrival that are made up with GPS waypoints. Most airports, though not all of them, will have, along with their standard RNAV GPS arrivals and departures, conventional departures and arrival routes. Although the capacity of these routes will be very limited compared to normal operation, they can be utilized along with RNAV departures flown by aircraft that might still be able to navigate with the help of their inertial navigation system. All of that is considered while the workload during this ATC reversion protocol has to be kept to a minimum both for the pilots and the air traffic controllers. The procedure that is applied during a partial or total GPS outage will vary from country to country. It will always be a combination of vectoring aircraft, reverting to a conventional approach and airway, and maybe even reducing the capacity within a certain flight information region. If you have any insights into how air traffic control would handle such a scenario, write it down in the comments below. Consider giving me a like if you liked the video and subscribe if you want to see more. Until the next one, stay safe.